Hi friends, let's wait for 2 to 3 minutes so that others will join the session. Okay, let's begin our session. We have been discussing about Kubernetes. We have seen how to create Kubernetes cluster in AWS. The AWS managed service for Kubernetes is EKS, stands for Elastic Kubernetes Service. And we have seen how to connect to the AWS account from our local machine using AWS CLI. For that, we need to provide the credentials. And after that, we need to execute a command to get the config file of the particular Kubernetes cluster which we are interested in. So that can be done with the command. What's the command? This is the command. We will give AWS EKS region. In which region your cluster is there? This is the cluster name. This is the region, and we want to update the kube config. If some kube config is already present in our local machine, otherwise config file will be created in the .cube folder, which will be created in the C drive. Then this is the name of our cluster. So with this, what will happen is the kube config file will be downloaded into our local machine. So with that, we will be able to access the cluster. Then I want to see the number of nodes that are present in our cluster. For that, we have a command called kubectl get nodes. We have two nodes. This is one node. This is another node. Okay. So after that, I said that the smallest deployable unit in the Kubernetes is pods. So we will always get the pods, but not the containers directly. So that means I want to see the number of pods which are there in my cluster. For that, we need to give kubectl get pods command. And if you get this information, see no resources found in default namespace. Of course, what is namespace you will understand later. Okay, let's suppose that we don't have any pod particularly about this default namespace. Of course, there are some pods which are already running in another namespace. When the time comes, I will tell you. I'm trying to list out these pods which are there in our cluster. So where this particular command went, the command goes to control plane and more specifically to API server. When this command goes to API server, the API server will contact etcd database, which stores the information about the cluster in the form of key value pairs. Then, so this kube API server gets the request From where it will get the request? This is our cluster. I am representing the cluster something like this. Now we have connected to this particular cluster from our local machine, and that too with kubectl command line. Now we have given a command called kubectl get nodes. So this command goes to control plane and more specifically to KubeAPI server. Okay, as we discussed, KubeAPI server will act as the entrance to the whole Kubernetes cluster. Then we want to get the number of nodes in the cluster, where that information will be stored, from which component this KubeAPI server will fetch the information and give output to us. So that information will be stored in some database called etcd. So KubeAPI server, once it gets the request from the client, it will ask the information from etcd, and etcd will give reply saying that in our cluster we have 2 nodes. Okay, and please do remember that when we are applying this command, only 2 nodes are showing, but not the control plane. By default, control plane is control plane, it's master, it's not node. So nodes are nothing but something like the things which carry the real workload. That means which carries the containers. In control plane, pods won't be scheduled. Only on the nodes, the pods will be scheduled. So when we apply kubectl get nodes command, the information will be coming from etcd, and etcd will give that information to KubeAPI server, and in turn it will output the information to us. That output is this one. Right. Then if you search for pods, there are no pods in our default namespace. Okay, so if you don't know namespace, I don't expect you to know the concept of namespace. We will understand that later. Now there are no pods, but I want to create a pod for Nginx. For that, there are 2 approaches for that. One is imperative approach, using in which we will use the imperative commands to get the desired state. But we have the declarative approach, which is more ideal solution for this Kubernetes service, which we will learn slowly. Now, I'm trying to create Nginx pod. So the command is kubectl run, and hello-nginx is the name of the pod that we want to give. The name of the pod that we want to give. That means this pod name can be anything. Okay, and we want that pod, okay, to be created from which image? This Nginx image. How do we specify the image here? --image equals to Nginx. And if you want to get the specific tag of the Nginx, we have to give that tag here. Okay, what are tags? We understood during the Docker. The same tags here also, because this Nginx image will be fetched from the Docker Hub by default, and we will also see how to fetch this from our private container registries during the course. Now, if I apply this command, Nginx pod will be created, and that pod name will be hello-nginx. Let's hit enter. See what it is saying? Pod hello-nginx is created. Now, if I use kubectl get pods command, now we should see that this Nginx pod is running. This is pod. In this pod, we wanted to have one container, and that container is ready. Okay, so here this thing is what? Containers. The status of the pod is running. There are no restarts. Okay, we will understand restarts, and it is created about 11 seconds ago. That's fine. Now kubectl get pods. That's the pod. Now I want to get the details about this pod. For that, kubectl describe pod. kubectl describe pod. Which pod? Hello Nginx pod. So if you see, we got the output in the form of ML. See, name of the pod is this one, namespace, priority, service account, node. On which node this particular pod is running? On this node. On this node. In our cluster, we have two nodes. Who will schedule the pod on the nodes? Scheduler. Scheduler will decide the node in which this particular pod has to be created. And out of these two nodes, it will create that single pod any of the node. Okay, and it is created on that particular node. And this is the time, these are the labels which we will understand later. See here IP, this is the IP address of the pod. And inside there, inside the pod, what will be there? Content will be there. We created pod. What is the pod name? The pod name is Hello Nginx. And inside that, what will be there? Inside this container will be running. This is the container. So containers, how many containers are there? Only one container is there. That container name is Hello Nginx. So the whatever the pod name that we are giving, the same name will be given to containers. But this we can change, which we will see in declarative approach. And this is the container ID. This is the image. This is the image ID. See, this is the image ID in the Docker Hub, and other details here, the port, host port, and other things. We did not use the port now. Then, so this is the thing. This is the place where the particular secrets of the Kubernetes will be saved, and container is ready, pod is scheduled. And if you see here in the events, okay, we will understand this node selectors and tolerations, everything, this volumes and everything. So for everything, a dedicated section will be there. Now, first, what happened? First thing, scheduled. Okay, so default scheduler. So this is the default scheduler. Successfully assigned Hello Nginx pod, which should be created in the default namespace. This pod is successfully assigned to which node? This node. This is the event. After that, kubelet is giving. So once it is assigned, then the responsibility goes to kubelet. Okay, the kubelet, which kubelet? The kubelet that is there in this node. That is there in this node. Now that kubelet is giving message saying that it is pulling the image. Who will pull the image? Docker, which is there in that particular node. So that image is being pulled, then image is successfully pulled, then the created container and the container is started. Container is started. So that's why we are able to see the status as ready. Got it? So that is how the flow will be. Then it has internal IP address, right? But how to access that from outside of the cluster? And let's try to access with the internal IP address. Now, what I will do is I will create an Ubuntu pod. I will create an Ubuntu pod. How to create that? Again, kubectl run. What's the name of the pod? Let's give it as my Ubuntu. Then was the image. Ubuntu is that image. But it will be, the status will be completed. See, because there is no process running in that. As soon as content is created, it will be executed. So what I will do is, let's interact with it. See, successfully content is started and then it will be stopped because there is no process running in this. Now, what I will do is I will interact with it as soon as it is created. Let's delete this pod. How to delete a pod? kubectl delete pod my Ubuntu. I'm deleting this pod altogether. Why this is in crash loop backup state? Content pod is created. Inside the pod, one container will be there, and that container created and it ran and it went off. Why? Because there is no application running in this. What I will do is, let's interact with that particular pod. So for that, we have -it, we want to interact with it. Like in Docker, we also have that here. That is -it. Then here we need to specify the shell. So here, what will happen? From Ubuntu image, this pod will be created. Once the container is started, we want to interact with it, and the shell of the container is bash. If I specify this, now where are we? We are into the Ubuntu container or Ubuntu pod, you can say. If we have multiple containers in the same pod, then there is different approach. In that case, we have to specify the container in which specify the container with which you want to interact. For that, we will be having -c option when we go to multi container pods. I will tell you them. Then here we are trying to interact with the pod. So that means indirectly we are interacting with the container only. Okay. So now we are into the container. This is the container directory structure. Now I'm using Control PQ. Sorry, that is for Docker. I'm confused. Let's use exit here. Docker, sorry, not Docker. kubectl get pods. So that is fine. That is restarted because we have exited. That's fine. You will understand this behavior slowly. Then what I will do is I will bring the IP of this one. How to get it? We can go to description or else kubectl get pods wide. We want to get the output, wide output. O stands for output. We want to get more details. So here, if you see, this is the hello engine export. Status is running. Out of one container is ready. There is no restart. It was created about 10 minutes ago. This is the IP address of the pod. This is the node on which it is scheduled. And this pod is also scheduled. Sorry, this is also scheduled on the same node. Okay, so the two pods are running on the same node. Now let's copy this IP address, paste it here. This is hello Nginx IP address. Now let's interact with it. kubectl exec id is the command like that of the Docker. This is the command to execute commands in the shell of the container or the pod my Ubuntu. Then we have to give -bash. With this, what will happen? We are into the container. Now let's clear the screen. We are into the container. Let's curl this IP. See, curl is not found. If it is not found, how to install it? Same something like in Docker. So that's why I told you every command, Docker execute command, we have pinged one container from the other with the IP address, with the host names and all. So during this debugging process, they will help. But on daily basis, you won't be able to, you won't interact with the container every time. You will just deploy the things and in the pipelines they will be running. But if there is any necessary to go inside the pods, then this is the approach. Now what happened? The call is not there in that particular container. Let's install that. apt update, then apt install IP utils. Sorry, just call. So call will be installed. I'm not installing that in my local. I'm installing that in the Ubuntu container. Now let's call it. See what happened? Nginx page is open. Nginx page is open. But if I use this command in the browser, will you be able to access it? No, because that is internal IP address, which is internal to the cluster. But that Nginx is a front-end application. We should able to access that from outside of the cluster. How to do that? For that, we have to expose it. When we are exposing means a service object will be created, which we will learn later. But to give some feel about the Kubernetes, I'm just running this command. You will understand everything related to that later. Now let's exit from this pod. Now we are running this. So we are trying to expose pod, which pod? Hello Nginx pod, to a load balancer. Then, and the port of the load balancer is 80. The service object, that is service object port. You will understand the container port, service object port. So now what happened? It is saying service hello Nginx exposed. So that means service with this name is created. How to check that? kubectl get service. Don't worry if you don't understand this. We will be having a dedicated section for this. Now, see, this is the load balancer IP address and port is 80. So by default, HTTP will be running the port 80. What's not running? Okay, it will take some time. Then, now I want to explain one concept where this load balancer came from. This load balancer is given by AWS. How? Because we are using EKS cluster and here we have a component called Cloud Controller Manager. Cloud Controller Manager. This component is responsible to wipe this cluster with the AWS. So we got this external IP as the load balancer. And if we go to AWS account, so first let's see this now. See, Nginx is being opened. If I give this to you, you should also be able to access it. I'm just pinning this in the chat box. Can any one of you please hit that and tell me whether you are able to access? Anybody in the world should be able to access my Nginx now, because I have exposed this to the outer world by using the load balancer. Now, that load balancer is given by the AWS. If you are using, yeah, Ashutosh is able to access, means everybody should be able to access. I don't recommend you to use Minikube, because if you're using Minikube, then you won't be getting that load balancer there. Now, if I go to AWS, if I go to EC2, here, if you go to load balancers, see, this is the load balancer that is created for us. And this load balancer is, this is the load balancer, this is the load balancer that we got here. Now, what is load balancer, what is node port, what is cluster IP, we will understand slowly. But I'm just giving some overall picture here, how we will be deploying things. So that is how imperatively we do the things. Now, so this, we have created a pod. Inside the pod, container will be running. Then we have created a service object called load balancer. And we are trying to hit that from the external browser. So with that, we are able to access it. That's fine. Now, the whole purpose of Kubernetes to provide us with the high availability. Here we have only a single pod. But what if this pod is deleted? Why to have Kubernetes? If you want to have a single pod, you can achieve that through the Docker, where you can have a single container. But in Kubernetes, even if one pod is deleted, we want to have the desired state of the pods always up and running. The desired number of pods always up and running. So usually we don't create naked pods. Naked pod, I mean to say the single pods. We have some other higher level objects through which we will create the pods. Okay, so those higher level objects are called, one is deployment. This is the most frequently one. Now, I'm telling you again, initially what we did, we tried to create a pod, and that pod name is Hello Nginx. Now I can create another pod. Okay, that pod will be created, and this is different pod. Of course, it is created from the same image, but this is a different pod. But this pod is running one application, this is running another application, because they are independent pods. I did not specify anywhere that they both should run the same application. No, I did not specify anywhere. It is different application, this is different application. Okay, of course, Nginx server is being used in the both the deployments. But how to have multiple replicas for the same pod? That we cannot do with this command. That means when we are using this command, that means we are trying to create a simple pod, which is very lower level object in the Kubernetes. But how to create multiple pods or multiple replicas or multiple instances for the same application. For that, instead of just creating a pod, we have to create some higher level object which in turn will create multiple pods for the same application. So that object is deployment. So that means we're going to create a deployment, and the deployment name I want to give is myNginx, and the image that we want to use is Nginx image. So now let's try to run this. You will understand the difference. Now I want to name it differently. My deployment. I'm naming it so. Create deployment, my deployment. So that means what will be created? Deployment object is created. Earlier, pod object is created. Now, some higher level object called deployment is created. And in this deployment also, what we are giving? We are giving the image only, because ultimately this deployment called my deployment will be having pods only. Okay. Now, kubectl get deployment or deploy, anything you can use. Let's use this now. So now what happened? The deployment has been created. In that, we wanted one pod is there, and that one pod is ready, and that is available, and that is up to date, and it is created 48 seconds ago. Now, I said that as a part of this deployment, what will happen? Only pod will be created. But here, earlier, the pod is directly created when we use kubectl run command. But in this case, a higher level object called deployment is created. And as a part of this deployment, pods will be there. This is one pod. Okay. But why to create a deployment when we have run command? If you create a pod using run command, what will happen? Only a single pod will be created. You can't scale it up. You can't scale it down. If you are creating a pod, means just it's a pod. You can't have multiple replicas for that. You can't scale it up or scale it down. To have the features of scaling up and scaling down, we have the object called deployment, and deployment, as a part of this deployment, internally at the lower level, pods will be there, but these pods are being controlled by this deployment. Now, this deployment have the ability to expand. That means we can scale it up and scale it down. Now let's try that. How to scale it up? For that, so this expose, let's keep it aside. We want to scale the deployment. Which deployment? kubectl. Now let's see the pods first. See, this is our earlier pod. This is our second pod. This is the pod that is being created by this deployment. Now let's get rid of the earlier pods so that there is no confusion. kubectl delete pods. How to delete pods? We can specify the pods in a row by separating them with the spaces. So those pods are deleted. They are being deleted. Take some time. That usually don't take that much of time. Okay, so those were now deleted. kubectl get pods. So this is the pod which is a part of this deployment called as my deployment. And how that pod is named? It is named something like the deployment name and some random hashtag being assigned to this. You will understand this slowly. And in this pod, one container should be there, and that container is ready and it's running, and it's created about 4 minutes ago. Now, how to interact with it? Same thing. kubectl exec it, the pod name you have to give, okay, and you have to specify the shell at the end. It is taking time. Yeah, now we are into the pod. When we are into the pod means we are into the container. Okay, so let's exit from this. Now, what I will do, let's scale it up. How to scale? We have to scale the deployment, not the pod. Get deployed, get kubectl scale is the command. Scale deployment or deployment, my deployment. Hyphen replicas equals to how many replicas we want to have? Let's have 3 replicas. Okay, kubectl get pods. See, 3 pods are running. So this is the deployment name, and this is replica set, which you will understand later, and this is some random hashtag. So this is how they were named. Then let's go to the deployment, get deploy. This is, let's describe this, describe deployment, my app deploy. So we can describe any object with this command. So these are the things you will understand, this replica set and everything going forward when we are using the declarative approach. Then kubectl get pods, that's fine. Now what I will do is I will delete a pod. Delete pod. Let's delete this pod. The pod name is 1W. We have deleted the pod. Now see what happened. In its place, again, a new pod has been created. See, these are there, and we have deleted this one. Once we deleted this one, but still, immediately after deletion of that, we got another pod in its place. Now the total became 3. So this is called auto healing in Kubernetes. Because we wanted to have 3 replicas, so that's why always the desired number of replicas will be ensured to be up and running. That means we will take care of that activity. Controller manager will be having a component in this called controller manager. And more specifically, a replication controller will do the job of replication, and in case if any pod is failed, then it will bring up a new pod in its place by killing the older one. And here we deliberately deleted the pod and it was created. Now let's delete all those pods. Delete pods, delete pod. But still we have 3 pods up and running. Once they got deleted, immediately in their place, new pods will be created. And in these pods, the same application will be running. Please do remember that we have deleted the pods, but not the deployment. The deployment is there, but we are deleting the pods. Okay. So now if you delete this deployment, everything will be deleted because we ourselves want to delete the deployment. How to delete it? kubectl delete deployment, my deployment. Sorry, my deployment. The deployment name is my deployment. So with this, what will happen? The deployment will be deleted. kubectl get pods. See, there are no pods. Once we delete the deployment, that is the higher level object. The pods which are created by the deployment will be deleted. So that is one object, and this is how to create that. And if you want to expose it, it will be exposed. You can use it, but that's not my intention. If you want to edit it, we have a command called edit. We don't use on this. We will use edit command because some way we want to debug the things. Now, if you want to edit it, what's the deployment name? MyNGLX, right? If you edit, see what will happen. See, if you are editing, the configuration file will be open. So this is the, of course, you will understand this later. Okay, this is not the right time to edit it. So scaling up, scaling down means you will give the lower number. Same command will be there. If you have 5 pods running now, if you want to scale it down, you have to give the lower number than this. So that is called as the scaling down. And this set image we will understand during the ruling update things. Now let's not discuss about all those things now. Anyway, we are going to discuss clearly from this. This is the declarative approach. What we have done, first we have created a deployment, and after that we want to get the design number. We have to run another command called the scale command. We want to update the image, we have to use the set image. So to get the desired state, we are running one or the other command time and again whenever necessary. But that is not the thing. Why? Because we have to have a mechanism where we can store the configuration of our application in the repositories. So that can be done using declarative deployment approach. In declarative deployment approach, we will specify the desired state and the container that should be created, the container image that should be used, the container registry server that should be used, all those things, the ports that should be mapped, all those things will be defined or specified in a YAML file, in an YAML file called Kubernetes manifest file. Now, an ideal approach to deployment with the Kubernetes is the declarative approach. Kubernetes knows the state you desire your servers to be in, and Kubernetes figures out a way to implement that. Which one? The file which you will create. Kubernetes performs container orchestration by using definition files, and these definition files are also called as Kubernetes manifest file, which will be there in the YAML format, and they are YAML file. And please do remember, Docker files are just simple text files. Docker compose files are YAML files. Again, these Kubernetes files are also YAML files. And each YAML file consists of 4 top level elements. Okay, so now let's create an YAML file. Which we will get pods. I just want to clean up if there is anything. delete deploy my convenience is the deployment name. So from this, I get to know that the deployment name is my maintenance. It got deleted. Now let's create some YAML file. Now let's name it as the YAML file can be named anything. Okay. Now demo pod.yaml can be pod or it can be anything. Okay, demo file. Let's suppose name it a demo file so that you won't be confused. And here it can be YAML or YML. Anything can be used. Nothing is valid here. And every Kubernetes definition file consists of 4 top level elements. What are those? One is API server. One is API server. Then another one is kind. Another one is metadata. Another one is spec. Every Kubernetes YAML files consist of 4 top level elements. One is API server, another one is kind, another one is metadata, and another one is spec. Relating to every Kubernetes object or the resource, a specific API server will be there. Is it API server? API version, friends. Yeah, I got confused. Sorry. API version. API version means, I will tell you that here. Depending on the Kubernetes object we want to create. So, depending on the Kubernetes object we want to create, just now we have seen 2 kinds of objects, 3 kinds of objects. One is pod we have seen deployment, we have seen service. Of course, we did not see the service fully. Let's suppose that we have seen pod, we have seen deployment. Those 2 things are called as objects. And depending on the Kubernetes object we want to create in the cluster, there is a corresponding code library we want to use. So that version is nothing but API version. Where do you get the API version? From Kubernetes document. You don't need to have that knowledge already. You just have to go and use it. And for Kubernetes, the official documentation, official thing is Kubernetes.io. This is the, I think this is the documentation we will be using if you want to use. So here, API version for pod. This is an object. Sorry. Kubernetes. Why giving us the first URL? See. See, this is the API version V1, and in our notes you will find the list of all the API version for all the objects. So for pod, that API version is V1. For service also, the API version is V1. For namespace also V1. For secrets also, this is V1. For deployment, it is /V1. For ingress, it will be different. For persistent volumes, it may be different. For persistent volume claim storage class. So those are all Kubernetes object which we will learn slowly. So Kubernetes definition file consists of 4 top level elements. One is API version, another one is kind. So API version is V1. I want to create a pod. Then what kind of Kubernetes object you want to create? Whether you want to create a deployment, replica set, or what? We have so many objects. We want to create pod. Metadata means some information about the pod that you want to create. That means name. Name. You may create number of pods. How to distinguish those pods? For that, you have to name them distinctly. Now, let's name this pod as myAnjiReddy. Suppose that let's name it as myAnjiReddy. Corresponding to the command that we have executed, that name I am giving here. So that means once the pod is created, and the pod name will be this one. And we have another thing called a spec, which stands for specification. Here we will give the specification of the pod. What are the specifications? The image that should be used, the ports that should be mapped, all those things, the container name, everything will be specified in the spec section. And this is for pod, okay? And pod will be having different kind of spec than that of the deployment and that of the service and other objects. Every object will be having its own specification. Now, for pod, what are the specifications? Let's see name of the pod. This labels you will understand later. So in spec, we will be having containers. Okay, these are keywords, friends. This is keyword, this is keyword, these are all keywords. So containers you should do. It's not like I'm giving this, okay? It should be written in the spec. So containers. And I said that pod can have multiple containers, but let's have a single container in this pod. How to specify that container? So inside the container, containers is an array. How do we represent array elements in YAML? By using hyphen. So let's name the, what's the name? Name is there. What's the name of the container that you want to create? Now let's use something like Nginx container. I'm giving this name. This name can be anything. You can name it as C1 also, C2 also. It depends. Now this is the thing. For this container to be created, we should provide what? We should provide the image. What's the image we should provide? That will be specified using image. Let's use Nginx. If you want to use Tomcat, you can use. If you want to create Ubuntu, you can use. If you want to, somebody has asked yesterday that RabbitMQ, you can use that RabbitMQ here, right? So MySQL, if you want to run MySQL, so like that you have to give here. So let's stick only to this basic specifications. And now this is how you can specify the things. This is the definition and this is the state that we want to have. And let's deploy this. How to do that? For that, we have a command called kubectl apply or create. First, let's understand create. Because this pod is not created already, the pod called myNginx is not created already, we can use create command, kubectl create. Create from where? From file. What's the file name? Demo file. Just give day and just use tab. It will be auto filled up. Hit enter. We want to create objects which are declared in this file, and the file will be feeded by using -f. See what happened, what is there in the file. This is the thing. So we want to create a pod. So the pod, what's the pod name? myNginx has been created. How to see the pod? kubectl get pods. Got it? The pod. So this is something like what imperatively how we have achieved this. kubectl run myNginx -image equals to nginx. This is how we have specified. Corresponding to that command, this is the declarative manifest file for the same object. Now create. Now, how to delete this object? You can directly delete kubectl delete pod, and the pod name you can delete. But you can also delete kubectl delete f demo file dot YAML. So with this, what will happen is Kubernetes will delete all the objects which are created by using this file. What are the objects that are created using this file? This is the only object, and only that object will be deleted with this command. Hit enter. See, that will be deleted. You see here, get pods. Okay, so there are no pods now. We can use apply also. Apply demo file. Then, what's the difference between create and apply? If the myNginx pod is not created already, if you want to create afresh, you can use create. But if pod is already running with myNginx as the pod name, if you want to make any change in the spec or anything, and if you want to apply those changes, we can use apply. So apply means if you want to change some things in this, let's something like I'm going to add some label here, labels, some env equals to dev. I'm giving this. First, initially, let's create that without these things. Now, I can use this apply command also. This pod is not running. I can use this apply command also, no issues. But in case if you want to use create, that is fine. You can create, but that create command will work if the pod is not already created. Let's try to apply that file again. See what will happen. See, unchanged. Apply means we are trying to apply any changes to the file, and we did not make any change to the file. So that's why the status is unchanged. But let's try to use create. See, error from server already exists. Error when creating this one because the pod called myNginx is already existing. So that's why we can't create it because it's already created. But if you want to do any changes, then you can use the apply. So because we did not upload the updated, so it is not going to be affected. Now let's try to add some labels. You will understand the label slowly. One something like dev. Now let's use create. What will it say? You don't mind about the changes, whether the object with that particular name is created or not. So that's what the create command will worry about. Now let's use apply. If you use apply, what's the update now? Here the output is configure. Configure means whatever the changes that you have done from its creation to now, those changes were made. Okay, that is fine. Then this is the state that we want for the pod to be in. Now, if you want to describe this pod, use one thing. Get pods, able to get the list of the pod. If you want to describe it, describe the pod, myNginx. You will get its description. Got it? Now, we want to delete this, kubectl delete here. That means the objects which are created using that file will be deleted. That's it for today, friends. If you have any doubts, you can ask me. Otherwise, we can wind up this session. And one thing, friends, those who did not complete their payment formalities, please do it if you like this course. And tomorrow also you will be eligible for the demo classes. And on Monday, link will be changed. On Monday, link will be changed. Saturday, tomorrow class will be there. Sunday class won't be there. Again, on Monday it will be there. And Monday link will be provided to the people who have paid. Okay, and you have to check your mail for that new link. Okay, friends, thank you. Any questions you can ask me. Meanwhile, I will delete my cluster. And one thing is, if you have created any load balancer, first you have to delete the load balancer. If you don't delete the load balancer, and without deleting the load balancer, if you delete the cluster will be deleted, but load balancer won't be deleted. And if you have the knowledge of AWS, you must be knowing that load balancer is chargeable. Delete SVC. I want to delete this service. This command will understand. So with this load balancer will be deleted in some time. Let's wait for it to be deleted. Okay, that got deleted. Then now I can proceed with the deletion of my cluster. How to delete my cluster? First, we need to delete the node groups which are attached to it. I have to automate this, friends. I need to write the Terraform script for this because of paucity of time. We can make it. It will be easy for us if we have the Terraform script for this. Okay, friends. Let's meet tomorrow. Bye.
Laxman, I have a question.
Yeah, Payal, you can ask me.
When we create a cluster, but I want to provide access to anyone, that time what can we do?
You want to provide what?
Access to another person.
Access to another person.
Yeah.
Same thing. You have to give him the AWS access, and he has to get that access. If it is IAM access, you should provide him to the EKS through the IAM roles. And after that, he will be able to execute that AWS EKS, that region, and the cluster name command. With that, he will be able to give that. He will be able to download the config file in his local machine, and with that, he will be able to connect to the cluster using the kubectl client.
Can we see that in the lecture?
What? Didn't get you.
Will you teach that how to access the anyone?
No, you want me to show that?
What? Sorry.
I didn't get you. Can you please repeat that? You want me to show that also?
Yeah, how to access the anyone? You teach. You show that how to get the access to anyone with the demo.
Yeah, that's what I'm telling. First, the person should have the access to the AWS account where that cluster is there.
Okay.
Okay, so after that, he has to do the things which we have given in the documentation. Yesterday, I have shown you that, right? So the same thing he has to do. Yes, he has to configure the credentials in his local machine. For that, he needs to have AWS.
With the config file, yeah?
Yes.
Okay.
Yeah.
Thank you.
Okay, friends. Bye.